Before beginning a flight, we must become familiar with all available information concerning that flight, and this includes weather reports and weather forecasts, fuel requirements, and alternates available before beginning a flight. This may involve the translation, interpretation, and application of graphical forecasts. Graphical forecasts for aviation replaced text area forecast in 2017. They provide a forecast for the en route phase of flight and for locations without a TAF, with a temporal resolution of 1 hour, available up to 15 hours, and they're updated continuously. Aviation surface and cloud forecast graphics are a low bandwidth subset of the GFA and have a temporal resolution of 3 hours, available up to 18 hours, and are updated every 3 hours. Some things we need to be concerned about when using graphical forecasts. The GFA and the surface clouds products provide a snapshot of expected weather. It's important for us to remember that phenomena will change at either a regular or irregular rate at an unspecified time within the period. We need to avoid interpolating between valid times. The GFA displays segments, convective segments, thunderstorm, severe thunderstorm, tornado watch notification messages only during the valid time of the product. And in the graphic on the right, we see we have a number of convective segments for 2100 Zulu, which is up in the time box. Once we go further into the future where the convective segment, usually 2 hours, is no longer in effect, that will disappear, even though the convective segment is expected to continue beyond that time. So this is important to remember. This is strictly with the GFA product. Weather overlay point forecasts, and I don't know if my mouse is working here. For example, the thunderstorm symbol. Weather overlay point forecasts, these symbols, wind barbs, and cloud point forecasts may not represent adjacent conditions. Weather between points may be substantially different, especially in mountainous areas. Ceilings, visibilities, and cloud heights, bases, and top grids provide a range of values. Operationally, for ceilings, visibilities, and cloud bases, we need to round down to the lowest value. For cloud tops, round up to the highest value. For winds overlay, apply the most significant unfavorable values. In other words, we're going to the worst case scenario because we don't know exactly where within the parameters they fall. This illustrates the different precipitation symbols used on graphical products. The symbols indicate the type of precipitation, and the number of symbols indicate intensity. 2 symbols generally light, 3 symbols moderate, and 4 symbols heavy. These are available on the Aviation Weather Center's homepage, or not the homepage, but on the GFA products. If you go down to the legend, usually in the lower right corner, there is a box for symbols, and if you click that, you'll get a PDF file with all available symbols used on the particular charts. Visibility grid and weather symbol or weather obstructions overlay. The color coding is the grid, which indicates various visibility values. The symbols are an overlay, which indicates the type of precipitation and intensity shown. In this particular example, in eastern Alabama and western Georgia, symbols indicate rain showers. That's the type of precipitation. Intensity is indicated by the symbol. In this particular case, the symbol on the left in Alabama indicates a moderate rain showers, and the symbol on the right, light rain showers. If we go down to the legend, the weather probability or weather intensity is shown as a chance, 30 to 60%. This is probability. Weather probability, 30 to 60%. is the light color, and the darker colors indicate likely, which is greater than 60%. And we can translate that if we want to as the chance as being a chance, and likely I usually like to use widespread because it's greater than 50% probability. So here we have type, intensity, and probability. Additionally, the thunderstorm symbols indicate coverage. Coverage is defined as isolated, which is the light tint. Scattered, 30 to 50% is the moderate tint, and then the dark tint indicates numerous thunderstorms. That's the coverage in those particular areas. And the symbol itself indicates, again, the intensity of precipitation. The single lightning bar, typically light, and the double lightning bar indicates moderate to heavy precipitation. We're going to take a look at a case study. We're going to apply a graphical surface forecast to the Calaveras County Airport, located east of Stockton, California, in the Sierra Nevada foothills. The airport has an elevation of 1,328 feet, and Calaveras Airport lies in surface-based Class G airspace below 700 feet, HEL, and has a single runway with an RNAV GPS runway 31 approach. Here's an excerpts from the southwest region of the surface and clouds product. Operationally, select the lowest grid or overlay value in the vicinity and avoid interpolation. Round to the most significant operational value. At 1500 Zulu, surface overlay shows maximum surface winds in the vicinity, southeasterly at 20, gusting to 30 knots. Now, my little pointer will work here. Visibility grid indicates visibility 5 miles or greater because it's in the white area. And so we'll select the lowest value for that particular parameter, 5 miles. The clouds overlay to the west of Calaveras, overcast clouds, bases at 5,000 MSL. Now we subtract field elevation to obtain a ceiling of 3,600 AGL. So there's our forecast for 1,500, our point forecast for 1,500 Zulu. At 1,800 Zulu, winds remain the same. Visibility drops to 1 mile, as indicated by the magenta grid. And since the magenta grid indicates visibility is 1 to 3 miles, we have to go to the lower value of 1 mile. The grid precipitation indicates light rain showers in that area, and they're dark, so we're going to go ahead and go, well, actually, should actually be moderate rain showers for that time period. At 2100 Zulu, now the ceiling based on the grid west of Calaveras, which shows overcast clouds, bases at 1,500 feet, these are MSL. So if we go ahead and subtract field elevation, we get an overcast layer at 200 feet. This is most likely unrepresentative conditions in the foothills, but nonetheless must be considered. This is a particular product limitation, especially in mountainous areas with these products. Using these operational values, we can develop a forecast for Calaveras Airport between 1,500 and 2,100 Zulu. Taking the most significant parameters between 1,500 and 2,100 Zulu, we have winds out of the southeast gusting to 30 knots, visibility 1 mile, light rain showers, overcast clouds at 2,100 feet AGL, becoming between 18 and 2,100 Zulu, 200 overcast. And again, this is that particular parameter is a limitation on the forecast. And this reflects the scope and limitations of these two products. Forecasts require, if we would go into instrument flight rules, require the designation of an alternate with appropriate fuel reserves. And best practices would suggest an alternate with a TAF. For this, for example, in this area, probably a good alternate might be Sacramento Executive or Stockton or even Modesto. And those airports do have TAFs. For VFR, this particular forecast would not necessarily preclude VFR in Class G airspace. However, we should keep in mind that legal does not necessarily mean safe. Now, what we can do is go to the graphical forecast for aviation to get a second opinion and actually a little better forecast. And this is the GFA, which is available on the AWC weather site. And it shows for the time period between at Calaveras Airport. And by the way, this is one of the nice features about the GFA product is that we can actually go down and zoom in to pretty much anything we want to. And also, we have the flight path tool, so we can get exact location on our particular location, in this case, Calaveras County. At this particular time period, the ceiling is in the light blue area, which indicates between 2,000 and 3,000 feet. And again, we're going to round down to 2,000 feet. So based on this forecast, or on this particular product, we can revise our TAF for Calaveras to indicate winds out of the southeast gusting to 30 knots. We still have to use the visibility 1 mile, although we could go to the GFA product visibility and possibly refine that. Moderate rain showers with a ceiling of 200, overcast. Now, that would be our forecast for our destination. If we look at the actual METARs for this particular time period, we see that between 1800 and 2100 Zulu, surface winds are generally out of the southeast and pretty much what with forecast at 20 gusting to 30 knots. The visibility is decreasing over the time period from 10 miles to down to 4 miles, and clouds are lowering, which is exactly what the graphical forecast had indicated. At 1800 Zulu, winds are still southeasterly. They're a little bit lighter. Surface visibility has decreased to 2.5 miles in mist, and cloud conditions scattered at 3,200 with a broken ceiling at 4,000 feet. And notice the remarks. Visibility is variable between 1 1/2 and 5 miles, which again validates pretty closely with what our forecast indicates. If we continue on toward 2100 Zulu, winds are quite variable, but they have decreased in overall velocity, just as the graphical forecast would indicate. Visibility continues to improve, and sky conditions are pretty much in the ballpark, and they're running around 2,500 to 3,000 feet. So this verifies quite well with the graphical forecasts. Operationally, if we're making this flight, we want to update weather en route, check METARs for destination and alternates. We also want to check TAFs, especially at TAF update times, and Jane very nicely showed us the TAF issuance times during her presentation. We want to monitor fuel reserves. It makes no sense to get into a marginal VFR weather condition without enough fuel to get to an alternate. Things we might want to consider operationally: land short or divert. Sometimes it's better to land short of a destination that may be marginal, or divert before conditions become untenable or fuel becomes marginal. Should conditions approach or deteriorate below regulatory or realistic personal minimums, we all have personal minimums, right, including surface winds, this again would be a good indicator to go ahead and land short or divert. If we're on an instrument approach, we do not want to hesitate to execute a missed approach should circumstances warrant. I was flying the Mooney from Livermore up to Calaveras in a situation very similar to what our example. I had flown out of Livermore. There were scattered rain showers in the area, and as is typical, the Sierra Nevadas had more cloud layers because we have vertical motion due to upslope in the mountainous areas. Even though Calaveras was reporting technically VFR with ceilings of about 1,100 overcast and a visibility of 3 miles, as I got closer to Calaveras, and remember it's kind of behind the first ridge, my plan was to go IFR, I follow roads. I was going to fly Highway 49, which goes right by the airport. As I approached the pass going into the valley where Calaveras is located, I ran into light to moderate rain. Now, those of you that have flown in rain, especially in aircraft that, in aircraft that do not have windshield wipers or some type of method to clean the windshield, you understand that forward visibility in rain is almost nil, but you do have pretty good sideward and downward visibility. Unfortunately, flying the Mooney with the low wing, and I'm sitting right on top of the wing, my downward visibility was considerably restricted. And there are mountains, and the mountaintops were being obscured on both sides of the route into Calaveras. And this is a particular case where, even though it may have been legal, it certainly was not safe, and I abandoned the attempt to go into Calaveras and diverted to Sacramento, where we had to leave the airplane overnight until conditions improved. So these are some of the things that you want to think about. Limitations on graphical forecasts. Weather symbols are point forecasts and may not represent surrounding conditions. We discussed this earlier. Displays may suffer from clutter, especially the graphical forecast for aviation. Like aeronautical charts, the amount of data or information put on the chart that may be useful to one person may not be useful to another and may actually obscure important information. This is one of the distinct advantages for the graphical forecasts for aviation, which are available on the AWC's website, because the amount of information is customizable. You can go into the settings window and put in certain amount of information or certain particular information that you're particularly interested, and delete or remove from the graphic information that is not of your particular value to your operation. No amendments are given for these products, although weather advisories, AirMets, SIGMETs, etc., automatically amend the forecast. These products are automated, may not be as accurate as forecasts with human involvement, for example, weather advisories and TAFs. As a matter of fact, if we had a human writing a TAF for the Calaveras airport, the forecaster could probably give us a little better time frame on when conditions would deteriorate and when they would improve, and also a better forecast of visibilities, weather, and ceilings that are not available with the graphical products. Operationally, use all available information and apply personal minimums. All available information includes satellite and radar, as well as PIREPs and any other information that may be available to your particular flight. But it's important not to overlook this information when planning a flight, especially into marginal conditions. There are some distinct advantages with the graphical products. The GFA suite is updated continuously. Displays are scalable and customizable. And the temporal resolution on the GFA suite is 1 hour. The aviation surface and cloud forecast, 3 hours. Forecasts are available out to 15 hours for the GFA suite, and the aviation surface and clouds forecast, 18 hours. Some things to keep in mind. Every theory of a course of events in nature is necessarily based on some process of simplification of the phenomena, and is to some extent, therefore, a fairy tale. This was written and published by Sir William Napier Shaw in his Manual of Meteorology, published about 100 years ago, but it still has quite a bit of truth to it. Watch out for absolutes. Weather is complex and dynamic. There are few, if any, never or always when it comes to the weather. Many weather phenomena are transitory, turbulence and icing particularly. If we have an advisory for turbulence or icing, the phenomena typically moves through an area, affecting one area more than another, and so we have to keep this in mind. And I think one of my favorite quotes is from AC 006 Aviation Weather, the 1965 edition. The weather-wise pilot looks upon a forecast as professional advice rather than as the absolute truth. A couple of things to remember. We mentioned this a little bit earlier. Safe does not necessarily mean, or safe does not mean risk-free. And legal does not necessarily mean safe. We have to apply our own personal minimums to every flight situation. I have my email address down on the bottom of this particular page, weathertheory@comcast.net. If you have any questions about this particular presentation or anything that has to do with aviation weather, send me an email and I'll see what I can do. If I don't know the answer, I'll just make something up. Okay, and that concludes the presentation. Don, if you'd like to go ahead and we've got some time for we may have some time for questions, or if you want to move on, whatever you prefer to do.
Perfect. Thank you so much, Terry. Great job as always. We do have a couple questions, and just while I'm answering the questions, Ken, I'm going to be passing the presenter role to you in the meantime. So, Terry, the first question we have here is, what is the best way of getting en route weather?
Oh, as Flight Watch, which used to be probably the best way, actually, and it really kind of outlived its usefulness in the digital age, went away a few years ago. There are a number of ways. Most, if you're going IFR or getting radar traffic advisories, the controller most often can help with weather in their local vicinity, but weather outside of their operational area, they typically don't have that information. So the best way in that case would be flight service, any of the flight service frequencies, and that's one of their primary jobs as far as in-flight is updating weather information. Now, if you are IFR or obtaining traffic advisories, you can usually go off frequency, coordinate with the controller, tell them you're going to go off and talk to flight service for a weather update. Most often they have no problem with giving you a chance to get off frequency and update weather information, especially if it's not in their particular vicinity. Don't wait till the last minute. If you're in congested terminal airspace, that's not the time to request a frequency change to update weather. So try to get it as far in advance as possible. If you're VFR, certainly flight service is the best way to update weather information.
Perfect. Thank you so much, Terry. I'm not seeing any other questions right now, but I am going to address, I see there's somebody with a sound problem. If anyone is having sound issues, I'll actually type it in the chat as well. The microphone on the top portion of the page, there's 5 little circles. If you do the drop down on the mic and do settings, you can adjust your sound that way. And I believe another member of our team is in the chat typing with the problem as well. Otherwise, I am going to switch it to Sarah. She can introduce Ken. And Ken, I'm also unmuting your phone line.
All right, this is Sarah again. I just want to introduce Ken. Ken Minsky, in his own words, is getting old and has been at ZOA, which is CWSU in Oakland, since 2004, but he likes it there. In general, Ken grew up in the Midwest, so he's used to severe weather in Kansas, graduated from the University of Kansas in atmospheric science. He's had past experience in the U.S. Air Force, Kansas Air National Guard, as a weather observer and forecaster. He's worked at offices in Pleasant Hill, Missouri, and also continued into the U.S. Air Force an officer role